welcome everyone. Thank you for coming. My name is Alan Gates. I'm one of the founders of Hortonworks. I'm also part of the Apache Hive project and a number of other Apache projects. I've been working on Hadoop and related technologies for longer than I care to admit, actually, these days, for about 10 years. And I want to talk today about some work we're doing with the metadata that is initially in Hive, but I want to talk about how we're making that accessible also to streaming and some other applications. So I think it's good to start with motivation. Why is this interesting? Why do we want to do this? So I'll just walk you through some of these. And let me start by apologizing for my art. I don't have, well, let's just say art's one of the few classes in school I actually flunked. And I didn't have time to run these through the art department at work that actually takes my slides and make them look decent. So sorry, this is going to look like I just drew it on the whiteboard, because pretty much that's what I did. So let's start out looking at a very simple use case, which is ETL. Nothing amazing here. You have your data stored, maybe in HDFS, maybe in a cloud store like S3. You're using some tool, or probably realistically some set of tools, to do that ETL. Maybe Spark, maybe Hive on Tez, maybe something else. And the metadata for that is being stored in this cluster that you see. Let's see, I think that button's the laser pointer. Over there. So HMS here stands for Hive Metastore. And Atlas is your governance, Ranger for security. Again, you can choose different tools here. I'm not trying to say these are the only tools you'd use. I'm just putting examples up there. Happen to be the examples that we use at Hortonworks, but you could use other ones. But one of the key things to see here is you don't have to have Hive in this stack to have the metastore in here, right? Today you can use Spark as an ETL tool, still store the metadata in Hive's metastore. Some people do that. Then usually, once you've done ETL, you'd move to something like this, some data warehousing. Same data storage, same metadata over here in terms of Hive Metastore storing your runtime, data catalog, Atlas storing your governance, Ranger having security. Now, in my example, we're using Hive LLAP to actually execute those queries. But you see how these two systems between ETL and data warehousing are sharing all this infrastructure, data and metadata. It's all good. Bring the data in, process it with your ETL tool, run your queries with whatever your query engine is, and that all works. Now let's look at another use case. Obviously, streaming is very important these days. And you notice in this picture, everything changes. Your storage is no longer HDFS or S3. In this example, I'm using Kafka. Of course, there are other things you could use. This is by far the most common one on-premise, or even in the cloud, really. Maybe you're using Spark. You could be using Flink, and a number of other tools there. But notice that the metadata system here changed completely. Now in my example, I'm using the Hortonworks schema registry. I'll talk a little bit more about what that is in a minute. But basically, all the rest of that picture went away, right? Why is this a problem? Or, well, is it a problem? I assert that it is. So what issues do we see on those slides? Or on those use cases? I think we see several. One, if you're using the Hive Metastore with a non-Hive system, as I showed that you could on the first slide, you're still forced to pull in most of Hive in order to put in the Metastore. It's not horrible, but it's not ideal. The next one is kind of horrible. There's no ability to share metadata between streaming and batch. They're in different systems, right? Not only are you storing data in different places, you're storing metadata in different places. That limits your ability to share across those systems. That means that your tools that store data in HDFS, like your ETL tools, your query tools, can't see what's going on in the streaming half of the world, and vice versa. Your streaming tools can't see what's going on in the batch world. And it means that your administrators are required to keep up and maintain two separate systems. You're doubling the number of things they have to install, maintain, monitor, all that work. So what's the dream state? The dream state looks more like this. This is where we want to get to. In this picture you see you still have all your batch work here. You can do your streaming work, and the schema registry here is integrated with the Hive metastore. What do I mean by integrated with? I mean they're actually storing this or sharing the same storage. They understand the data that each has so that they can share. So let me talk through a little bit of what that actually means. We want to make Hive, the metastore, separable from Hive so you can use it without it. So if you're in, this picture, and perhaps you're not doing any batch work, you can still install the schema registry and the metastore, and it will work. No need to install the rest of Hive. We want to enable that. But more importantly, we want to unify these two things so that they can share each other's data. Now, I'll talk through some of what that looks like here in a minute, but I'm going to actually backtrack a little bit first and talk through what it actually takes to make this happen. And then I'll get to showing why, what it looks like when these things are unified. So let's talk first about taking the metastore and making it kind of an independent thing instead of just a part of Hive. So about 9 months ago now, the Hive community started discussing, what if we took the metastore out of Hive and made it something separate, something that everybody could use? Because we observed that a number of people are already using the metastore. Impala uses it, Presto uses it, Spark uses it. And we want to make it easier for these systems to use the metastore. We want to make it easier for the people who work on those to be involved in the project, right? We want to help make sure that everybody can share in using it as a metadata system. So we started working on separating that out. In Hive 3.0, which there's already been a branch cut for that release. The release should be fairly soon. The metastore is now releasable as a separate product, where you could actually, it can cut its own releases, it can be separately installed, no need to pull in the rest of Hive. So in 3.0, there will actually be a Hive 3.0 and a Hive metastore 3.0. Now, on to the to the nitty-gritty details. There are a few things in the metastore that depended very heavily on Hive. For example, acids, the acid compactor piece that compacts changes from acid that don't work in the standalone mode. So there's one or two small things like that that if that Hive needs that are in the metastore. If you're running the metastore without Hive, you probably don't need those things anyway, so it's okay. But we do want to add those in the future. We worked very, very hard to make this completely backwards compatible. So if you have some application that connects directly to the metastore via the Thrift API, that should all still work. I say should because I haven't finished the testing yet, but it should all work. And I will finish the testing before we do the release, so we'll know that it still works. All the config files don't need to change, right? You can still read the old configs, all that's still there. The only thing that we did have to change is if you actually write hook implementations into the metastore has the ability for users to write hooks that run inside the metastore server. There are some small changes. But even those are fairly small. I would like to see, and a number of us in the community would like to actually see this pull out and become a separate Apache project to make it easier for other people to get involved. I just think that really enables better collaboration and lets that project move at its own pace and do its own thing. We're still in discussion with the Hive PMC on whether this is a good idea or not, whether it should just stay as a sub-project of Hive or whether it should be part of its own project. Okay, so the question everybody asks me is, didn't we try this before? Didn't they call it HCatalog? Are you just selling the same old thing you were talking about 5 years ago? No, it isn't. It's actually pretty different. And let me explain a little bit why. HCatalog, the focus was not breaking the metadata, or sorry, the metastore out of Hive. The focus was enabling tools like, at the time, MapReduce and Pig, later Spark and others, to access that metastore, the data in the metastore, not just the metadata, but also the data access patterns, things like SERDES, object inspectors, input-output formats, so that when you were writing Java MapReduce code, you didn't have to go fetch Hive SERDES to understand the data. Right? So it was both metadata and data access. When we talk now about pulling the metastore out, we mean truly just the metadata. Now, the metadata includes what SERDE do you need to use this data, but it doesn't include that itself, right? We're not providing that. Partly because the world has changed a bit. Most of the file formats people use now bring their own SERDES to the table. You don't really need Hive to give you that anymore. Most people are using ORC or Parquet or text, all of which you can process without needing any extra help from Hive. So oddly enough, in this split out of the metastore, HCatalog actually stays with the metastore. It's still there. It's still usable by tools that use it. But because it deals with the read and write access of the data, it will actually stay inside Hive and not go out with the metastore into a separate module, which is not what people usually expect. All right. Now, let's talk a little bit about the streaming stuff I talked about and how this helps us move beyond just SQL use cases. Right? What can we do here that we couldn't do before? And I want to start by introducing a project that Hortonworks has been working on for a while, which is a Hortonworks schema registry. You might be familiar already with Confluent schema registry, very similar idea. The idea is you have messages flowing through your streaming systems, such as Kafka or NiFi. You need to know what the schema of those messages are, right? How do you keep track of that? The schema registry does that for you. It gives the ability to create a schema, give it a name, and then have different versions of that schema. Every schema in the Kafka world would generally be tied to a particular topic, right? Maybe this is your user events topic. You have a schema that describes that. But actually, let me flip that example a little bit and think about data coming off a sensor. You might have thousands of sensors out in the world, and they might have been installed at different times, so they are generating different versions of the data. And they're all out there installed. You have no option to go out, at least with any, well, it's not no option, but you're not really motivated to go out when you come out with a new version of the sensor and replace all the existing ones, right? They're still going to be generating version 1 of the data. A second version comes out, you start installing those. So now you're going to have messages in your Kafka topic, some of which are generating schema version 1, some of which are generating schema version 2. You need to be able to deal with that. This is very different than in the traditional batch world, where you would expect every record in a particular batch, at least, to have the same schema. So these schemas need to be able to any system dealing with this needs to be able to handle the fact that every message may have a slightly different version of the schema. So the schema registry enables this, enables you to have different versions and to define compatibility requirements between those versions. Are they required to be backward compatible, forward compatible, both, or neither? Neither doesn't actually sound very useful. I don't quite know why they enable that, but whatever. Those schemas are defined in JSON text, which is ugly but useful. And there's a REST API and Java API for programs and a UI for humans, which I'll show you in a moment. This is Apache licensed, and we're working on contributing this to the metastore now that the metastore is a separate module inside Hive, which is, again, this is another motivation of why we'd like to pull this out into a separate project, because it makes it easier for groups like this to come and say, hey, we want to use your metadata repository for our stuff and contribute to it. So this is a screenshot of what the Hortonworks schema registry looks like. You can see here this data type is Avro. This particular thing is a Kafka topic. There's the schema name up there, version 1. You have a second example here where it's in NiFi. And as I said, the schema's in JSON, which is ugly but readable. So you can get an idea of what this looks like. Now this is, in some ways, pretty different from SQL, right? There's some significant differences here, maybe not the same data types, not, the schema is certainly represented a little differently, the fact that different records can have different versions of the schema. But fundamentally, it's still keeping track of the schema of the data, and you'd still like to be able to share these. So now I want to walk you through what I see as the potential of this. And I want to be very honest, the slides I'm going to show you are not yet implemented, so hence the warning sign here. I'm not telling you that this is all done and beautiful and you can go download it. It was actually one of my goals to get it mocked up as a demo before we got here, but I ran out of time, so you just get slides instead of a demo. But all right, let's look at this from the schema registry perspective. If you are a stream processing application and you need to access data in Hive tables, how would that work in this world I'm proposing? So let's say you have this user events topic, and this is maybe every time your user does something on your web page, an event is generated, or maybe every time they interact with your app on their phone, or something like that, it generates an event of users. And maybe something that you want to do is a user encounters some kind of trouble, they call support. For the next 24 hours, you'd like to monitor that user a little bit more carefully, right? You'd like to watch, make sure that they're having a good experience, make sure if there are problems that your support people jump on it right away, that they don't have to call you again, basically, and say, hey, it's still busted, come on, get your stuff together. You want to make sure you're proactive in helping them for a little bit. Now the problem is, the data about who called your call center is not in Kafka, because that's not a streaming thing. It's in some Hive table somewhere. Let's assume you have a Hive table called support calls, and it records who calls and a little bit of a summary of what happened, but your Kafka topic here doesn't have access to that information because it's stored away in Hive. So what are you going to do? If these are shared across the same metadata system, that means that your your streaming application can view this Hive table as if it were a Kafka topic. It can go read this. Now, obviously, there's some questions here about how it actually reads the data and all that. It has to understand how to talk to Hive, but by connecting the metadata, it can now see this. Now, you can't do an on-the-fly join against Hive for every record that comes across your stream. That's just not going to work. Hive isn't built that way. But you can cache this table maybe every hour or every 15 minutes or whatever, and then do a join on the fly, right? So you can have your your application going out, reading that Hive table, pulling the data in, joining against those events as they come across, and flagging any ones that are from users that have called you in the last 24 hours. And now, if an event is flagged, it can be bubbled up to one of your support personnel, and they can get right on dealing with whatever issues the user has, rather than waiting for the user to call again and be doubly upset now because they've had to call you twice in this last day just to get their stuff to work. All right, let's look at it from the other direction. What if you are your Hive? Why would you care about this? So let's say that this user event stream that I talked about is eventually uploaded into Hive into a table called user events. And maybe that upload's done every hour. You're batching data off Kafka, stuffing it into Hive every hour, or maybe every 15 minutes or whatever. That's all fine. But if you want to do a query against your latest data, now you have a problem, because your latest data is in Kafka, not in Hive. And you could go to Kafka separately and do a separate operation on it, but you can't see the two together. You can't say, tell me trends for the last 24 hours up to the last minute. You can't answer that question in this scenario. If that Kafka topic is viewable by Hive as if it were part of the Hive table, not a Hive table itself, but a partition in a Hive table, then you would be able to read that data as part of your Hive query. All right. Hive sees that as if it's just the partition marked latest in your user events table. And then when you run a query, if you select the last 24 hours, that is defined as part of your table, and you're able to see everything that's going on in that Hive query. So this is key because now your users don't have to wait until everything gets loaded into your batch system to see it, right? They're seeing the latest and greatest data on the fly as it's coming across. So, as I said, this is definitely a little bit of slideware. There's work to do here. So what is the work to be done? We've split out the metastore. We're working currently on integrating the schema registry and contributing that into open source or into Apache. It's already open source. It's Apache license, but we're contributing that to the Hive project. And then there's going to be a fair amount of work to do after that for these things to be able to read each other's data, right? Just doing the metadata isn't enough. We still have to make sure that Hive knows how to read from a Kafka topic, how to read those, how to deserialize that data, but that information is stored in the schema registry. So the data is there. Hive just has to have access to the right classes. In the same way, your streaming application needs to know how to read from Hive. Again, Hive in its metadata records how the data is stored. Is it ORC? Is it Parquet? Is it JSON? Is it something else? So your streaming application just has to have access to those classes to be able to properly read the data. So the information they need is there. The work then is in doing the integration between the two. All right. So I talked a little bit too fast, apparently, because I'm approaching the end before I'm running out of time. I did want to put in here that I talked about a lot of projects. This is just to say most all of them are actually Apache projects, so I might not have remembered to say Apache everywhere along the way, but there they are. With that, I am done and ready for questions. So questions. And I'll throw you the mic or something. Oh, is it on?
Hello.
Okay, go for it.
Cool. What's the relationship between Apache Atlas and the Hive metastore?
Okay. So they are separate projects, but they do work together. And I guess I should have talked more about that. Actually, let me go a ways back here. Yep, there we go. So as you see in this picture, I have all three, the metastore, Atlas, and Ranger are all in that. We want to keep that cluster together, and why is that important? What the metastore has in it is runtime data, right? How am I going to execute this query? How am I going to run my streaming app? How do I interpret this data that's in the Kafka topic? That's all runtime information. What Atlas has in it is more governance and kind of classical metadata, if you will. And that really falls into a couple categories. One is what does this data mean? The Hive metastore is never worried about what data means. is just worried about how it's laid out. Atlas is worried about what does it mean? What's the definition of a user? How is the definition of user related to the definition of a paying user? Those sorts of things. What are the relationships between these events? Atlas also keeps track of data lineage. This data point started in a Kafka topic, went to this Hive table, then to this Hive table, was transformed by this Spark job, that sort of thing. And finally, Atlas is very involved in data governance. Is this personally identifiable information? Who can see this data? Do I need to mask it? Do I need to encrypt it? All those questions. Again, questions that the Hive metastore is not worried about. So we want these two things to work well together, and we spend a lot of time actually integrating them. But we want them, they're really responding to different users at different speeds. The metastore needs to respond very quickly because as jobs are getting started, they're planning how they're going to operate. So the metastore needs to respond to those things in a few hundred milliseconds. Atlas, on the other hand, is usually going to be not in the main loop. If Atlas is down, your jobs can still run. But it's going to have a human sitting there asking it questions, running queries, things that we would not allow against the metastore because we don't want somebody showing up and running some big query that slows down the metastore and all of a sudden all your jobs go, start missing their SLAs and stuff because they're running too fast. So did I answer the question?
So is the metadata from Hive metastore available in Atlas?
Yes. So what actually happens is as Hive and a number of other things run, they forward information up to Atlas. So if you went, for example, if you create a table in Hive and you have it all set up correctly, this isn't out of the box work, there's a little bit of setup to do. But if you have it set up, you create a table in Hive, a notification of that will actually be forwarded to Atlas to tell it, okay, there's a new table, here's the columns, all those sorts of things, right? Now, that's not done real time. So, and we're not necessarily making an effort to make it real time because, again, Atlas is not mission critical for when it's running. So when you create the table, if you immediately move to Atlas, it might take it a second before you see it pop up, but it will automatically show up there. And even as data moves through the system, if you have tagged a particular piece of data as PII or something like that in one system and it shows up in Hive, that tag will actually follow it into Atlas. All right, other questions?
Can you talk a little bit about
Yeah, it's on.
the high availability and disaster recovery capabilities?
Sure. All right, so a very good question. Is this highly available if this blows up? Am I all in one system that if it blows up, I lose my whole system? So the Hive metastore really has two parts. I showed it as one box here, but it's a thrift server sitting on top of a relational database. That relational database can be, it supports Oracle, Postgres, MySQL, or SQL Server. The Hive team doesn't worry about making those things highly available because there's lots of solutions out there for those. So if you want high availability, fault tolerance, et cetera, in your database, we offload that to you, the user, because we figure that's probably a choice you're going to want to make anyway, and because there's no use for us to try to replicate that functionality when it exists for all those options. The thrift server itself does not keep any state between calls. So you can have as many of those actual servers as you want in the system in order for high availability. So if you, and many people do this, you can run 2 of those, and you can even actually set up your Hive client so that it will switch between them. It'll try one, and if it doesn't get a response, it'll go to the other to support that high availability. So these are not a single point of failure in terms of your system running.
Is there any plan to use HBase as database?
There was. We worked for a while on using HBase as the backing store for the Hive metastore. We really ran into a couple problems. One was HBase is a lot of work to configure and maintain. And when we went to potential users who were very comfortable running a relational database and we told them, hey, we're going to put HBase under here, they kind of looked at us like we told them they could only have broccoli for dessert for the next year. They just weren't excited about that opportunity. So that was a little bit of a mismatch there. The other was HBase, you have to know what you're doing to get HBase to work in the cloud effectively and economically, right? You have to configure it very precisely and all these things. And it wasn't clear to us that that was something we could automate well enough for users where they weren't going to be forced into a maintenance headache when they tried to use it in the cloud world, right? We want a product that's very easy to install and configure, and it just wasn't clear we were going to be able to get there. So we actually backed away from that work on putting it in the Hive metastore, in HBase. The other side of that is we've started doing a lot of work on aggressively caching metadata in the metastore and found that that got us about 80% of where we wanted to go on the performance. And so the HBase side became less compelling. So as the costs appeared to get higher and the benefit appeared to get lower, it just we decided we weren't going to keep pursuing that angle.
I believe that at the moment, authorization and authentication are implemented in the clients of the Hive metastore. As the Hive metastore becomes more of a critical centralized piece of infrastructure, does it make sense to move those functions into the Hive metastore itself rather than implement them each time in each variant of client?
That is a wonderful question that I don't think we have an answer to yet. We've started to ask that question, and what is the proper level of authorization and authentication we want to do there? Because right now, the only thing we have really is, there's two things. There's Kerberos on the Thrift client, right? So we can at least keep you from talking to us if you're not supposed to, if you're not authorized to. And we can do file level based security so that if you come and say, drop this table, but you don't own the table, or you wouldn't have rights to drop the underlying file, we won't drop the metadata. But that's it, and it's pretty rudimentary. I don't know off the top of my head whether it works on S3 or not, but I would believe you if you told me it didn't, because I think you use S3 more than I do. So does it make, what is the right balance of security to push out? Because the thing is that different use cases are going to have different security models. Like SQL security model is really different than a streaming application security model, right? So we have to think about how are we going to balance the need to, as you said, not make everybody implement security over and over and over again with the need to enable them to share. And I don't have an answer for you on what the right balance is yet. I don't know where I'm at on time here. Oh, I'm still good. Other questions?
So I'm curious in this unified vision here. So at the moment, the Hive metastore has an API which is in Thrift. The schema registry has an API which is REST.
Mm-hmm.
So I'm wondering, like, how much overlap is there between the APIs? Do you plan to unify them, or they can still be kept completely separate?
Again, that's something we're discussing. Clearly, REST is a good option for things like tools that are going to use a schema registry, right? And if you were sitting down from scratch to write the Hive metastore today, at least I wouldn't choose Thrift as the protocol. On the flip side, it's out there and everybody uses it, so it's awfully hard to just dump it. unless you just don't want anybody to upgrade. So I don't exactly know where we're going to land on that. We've just started that discussion in the community. The loudest voices right now want us to just move to gRPC and forget about the others. But I can't tell you where that's going to land. As far as the amount of overlap, the one thing I would say is the schema registry thinks about and presents metadata pretty differently than Hive does. So it doesn't think about tables. It thinks about schemas and schema versions. And so while there's overlap in the actual functions that you're doing, like tell me the schema of this thing, here's a new schema, there's actually a really different kind of presentation put on those. So the overlap is somewhat minimal at the moment. But I think your point in general is valid, right? That we need to figure out, it doesn't make sense to have one interface over here and another over there, and how are we going to unify that? So that's something that if you have strong opinions for or against REST, Thrift, gRPC, Hadoop RPC, I've heard that one too, you know, please come join the conversation, make your voice heard. Okay, more questions? All right, well then, thank you very much everyone, and enjoy the rest of your time here.